Assalamualaikum warahmatullahi wabarakatuh. It's an honor to be presenter in the second I-CMME 2022. I'm FANEA Fresti Antonieeta as a first author from Universitas Sebelas Maret, Indonesia. I'd like to present our research about parameter estimation of Biresponse nonparametric regression model with Fourier series. Regression models and their estimation methods have been developed. The estimation method here is the parameters estimating method on the regression function of the predictor variables that can affect the response variable. In the case of the unknown pattern or function, a non-parametric regression model is used because it has high flexibility. To estimate, it is assumed to be smooth and choose the appropriate function space that is believed to contain it. There are 5 estimation methods, namely kernel, spline, local polynomial, wavelet, and Fourier series. Jean Fourier was a French scientist who first proposed the concept of a Fourier series. The Fourier series is the series containing the terms sine and cosine used to represent periodic function in general. It has good statistical and visual interpretation data. The benefit is that it can be performed on trigonometric distribution data. The parameters used are smoothing and oscillation parameters. Several research have studied the non-parametric regression models with the Fourier series, i.e. Mardianto in 2020, Saputro in 2019, and Rautama in 2018. In its development, there are patterns of relationships between the two response variables that correlated with each other. So, the estimation should complete by a Biresponse non-parametric regression model. There are several studies with different approaches such as spline, kernel, and local polynomial. And now, in our research, we estimate the Biresponse non-parametric regression model with the Fourier series. If we give paired data, then the relationship between the response and predictor variables is written as this followed formula. With IR and observation, Y sub I represents the response variable, Fx sub I represents the regression function or the average function of the predictor variable, and epsilon sub I represents the residual or error, and assumed to be independent and normally distributed with zero mean and sigma square variance. The Fourier series is a trigonometric polynomial that has high flexibility. The estimation method with the Fourier series is the sum of a linear function and a trigonometric polynomial function, so it is assumed to be contained in a continuous function space. The approximation non-parametric regression function with the Fourier series is written as this followed formula. With B, A sub 0 and A sub k is a parameter with the Fourier series regression model. It depends on the oscillation and the smoothing parameter. The optimum parameter value can produce a minimum generalized cross-validation value. To estimate the parameter of the regression function is obtained by minimizing the value of penalized least square or PLS. PLS is an optimization method that provides a smoothing parameter on the least square method with optimization criteria that combines the goodness of fit and curve smoothness. For the non-parametric regression model, this is the size of goodness of fit component and this is the size of smoothness of the curve. The smoothing parameter controls the balance between the goodness of fit and the size of the curve smoothness. The two-response or Biresponse non-parametric regression estimation method is a generalization of the one-response non-parametric regression estimation method about the number of correlated response variables being 2. So, the Biresponse non-parametric regression model is written as this formula. With a number of g is 2 response variable and n observations. Between y sub 1i and y sub 2i, there is a strong correlation both logically and mathematically. F sub g x sub gi is an unknown regression function. Epsilon sub gi is the residual or error in the ith observation, which is independent and normally distributed with zero mean and variance sigma sub g square. Error epsilon sub gi are correlated with each other, so that they have a variance-covariance relationship from the error written as this matrix. If the relationship between the response and predictor variable doesn't follow a certain pattern, also have a periodic or seasonal pattern, then the nonparametric regression function can be approached using the Fourier series estimation method, so that the regression function is written as this formula. Then the nonparametric Biresponse regression model with the Fourier series estimation method is obtained by this formula, and it can be expressed in this matrix. The parameters estimation of the nonparametric Biresponse regression function is obtained by minimizing PLS, so that PLS can be written as this formula. Define this component as the goodness of fit, or GF. If the regression function is approximated by the nonparametric Biresponse regression function, then GF can be written as this formula. And define this component as the smoothness of the curve, or RF, with f squared x sub I is the second derivative of the regression function to the predictor variable, so that the smoothness of the curve can be written as this matrix. So the PLS can be written as this. Then the estimator beta, i.e. beta hat, is written as this formula, so that the estimated Biresponse nonparametric regression function with Fourier series is written as this formula, and it can be expressed by matrix G lambda sub 1 lambda sub 2 y. The best regression function is obtained from the optimum smoothing parameter to minimize estimation error. The MSE value is directly proportional to the GGV value and affects each other given by this formula. The best nonparametric regression model is obtained from the minimum MSE value. The GGV methods is a transformation of the cross-validation methods. The GGV formula is as follows. The best nonparametric regression model is obtained from the minimum GGV, and the coefficient of determination is the influence range of the predictor variable on the response variable, and the formula is as follows. The best nonparametric regression model is obtained from the largest coefficient of determination. This equation shows that the estimation is linear in the Y response and also biased because of E f hat x sub 1 x sub 2 not same as f hat x sub 1 x sub 2. From this, we can conclude that for this nonparametric Biresponse regression model, the estimation with the Fourier series is given by this formula. The best nonparametric regression model is obtained by the minimum mean square error and generalized cross-validation value, and the maximum coefficient of determination. The properties of the estimation of the nonparametric Biresponse regression function with the Fourier series are linear and biased in Y. We would like to thank Mathematical Self-Computing Research Group for the moral supports and incisive comment to improve this article. The research described in this paper is supported by a fundamental grant from the Research and Community Service Institute of Universitas Maret, took a letter of agreement for the implementation of the research implementation of the non-APBN fund. That's all our research. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.